Good morning students, myself Ashrit sir. Today we will discuss about your third chapter of your chemistry, that is elements, compounds and mixtures. Okay, as you know, matter can be classified into pure substances and mixtures. What is pure substance? Pure substance consists of particles of the same kind of matter. It is further classified into elements and compounds. See, I am showing the slide which is having your pages of your textbook. Underline what I have underlined already. Clear? So that these may come as a question. Clear? These are the important points you have to underline. So, what is an element? An element is a substance that can be broken down into simpler substances by any physical or ordinary chemical means. It may exist independently or combine with other elements to make many types of substances. But what is a compound? Compound is a substance made up of two or more elements. The elements in a compound are chemically combined in a fixed ratio. Clear? So, elements may exist independently, whereas elements are combined to form a compound chemically combined in a fixed ratio. Elements are represented by symbols, whereas the molecular formula represents the composition of a molecule of an element or compound. Clear? Then what is a mixture? Substances that are not pure are called mixtures. Mixtures are either homogeneous or heterogeneous. Clear? Now we will discuss about the compounds and their characteristics. I have given certain points 1, 2, 3, 4, 5. These are the characteristics of compounds. So you note it accordingly and underline in your textbook. First point is a compound is made up of two or more elements. For example, the compound water is made up of elements like hydrogen and oxygen. So the compound is always made up of in a combined ratio. The elements are combined of hydrogen and oxygen in a fixed ratio. Clear? As we discuss water molecule, what is the formula? H2O. So as you know, hydrogen and oxygen, two elements are there, but in a different ratio, 2:1, that is 2 atoms of hydrogen combines with 1 atom of oxygen. They are combined chemically to form water molecule. Similarly, iron nails, iron gates and all these things you might have gone through. What is rust? Okay, rust is the iron oxide. So it is a combination of iron and oxygen in a fixed ratio. Clear? The second point is a compound is always homogeneous. That is, a sample of compound are identical in all composition and have the same properties throughout. Suppose we will take an example, the property of drop of water, that is same property of a glass of water, even a drop of water, both are having the same property. Third point is the property of a compound are different from those of its constituent elements. Suppose the common salt, the table salt what you are consuming in your house, which you are adding in your preparation of food, that sodium chloride is a combination of sodium and chlorine, which are very poisonous substances. But when they combine to form a compound sodium chloride, it is quite edible and we are using in our day-to-day life. The fourth point is it is not possible to separate the constituents of the compound by any physical means. That means suppose we will take example as water, which cannot be separated into constituents, that is hydrogen and oxygen, by simple physical means like boiling or filtration. We cannot separate these two elements. However, it can be broken into its constituents by the process called electrolysis. Clear? The fifth point is when a compound is formed, energy is usually given off or absorbed. For example, when hydrogen and oxygen combine chemically, they form water, where energy is produced in the form of heat and light energy. Clear? So in the next slide, you see we will discuss about the mixture and the characteristics. What is a mixture? A mixture consists of molecules of two or more substances, maybe elements, compounds, or both, in any proportion, such that they do not undergo any chemical changes. But what we discussed in the compounds, the elements are combining in a fixed ratio and they undergo chemical change having a different property. Clear? But in case of mixture, they do not undergo any chemical change. For example, air. Air is a mixture of gases, as you know, such as oxygen, nitrogen and carbon dioxide. So many gases are present in the atmosphere. The molecule of one constituent of air are different from the molecule of other constituents. Similarly, some examples are there: muddy water, milk, honey, sea water, aerated drinks, petrol, cough syrup, paint and soil are the examples of mixtures. So what are the characteristics? The first point is the constituents in a mixture may be present in any ratio or proportion. For example, in a mixture of iron and sulfur, the amount of iron and sulfur is not fixed. You can mix them in any proportion. Clear? The second point is a mixture doesn't have any specific property of its own. That is, in a mixture, each constituent exhibits its original properties, which you cannot find in compounds. Some different properties will be there. So in case of mixture, for example, oxygen in the air supports burning, but nitrogen helps in the formation of protein. So they are having different properties. The constituent of air is having different gases and they are having different properties. The third point is a mixture doesn't have a fixed melting point or boiling point. For example, a mixture of glass of water with a spoon of salt will have a different boiling point from a mixture from the same amount of water with 5 spoons of salt. So it varies basing on the composition, the melting point and boiling point of the mixture. Next, the fourth point is the formation of a mixture doesn't involve any change in energy. Whereas in case of compound, what we discussed, there is always a energy changes takes place. But in case of mixture, there is no change in energy. Energy in the form of heat, light, etc. is neither absorbed nor evolved in the formation of mixture. The fifth point is the constituents of mixture can be separated by simple physical means. So how you will separate? Suppose iron and sulfur is mixed to form a mixture. Then by the using magnet you can remove the iron particles from the mixture of iron and sulfur. Okay, the diagram is given by the side, you can see. Then what are the types of mixture? There are two types of mixtures, homogeneous and heterogeneous mixtures. Homogeneous mixture, a mixture is said to be homogeneous. How? If its constituents are uniformly mixed and it has the same property throughout, then it is called homogeneous mixture. Understood? A mixture is said to be homogeneous if its constituents are uniformly mixed and it has the same properties throughout. Suppose we'll take an example, solution of sugar in water is a homogeneous mixture. You know it very well. The solution of sugar or the salt solution, all these are homogeneous mixture because you can take any spoon to have the same property of salty or sweet in the sugar solution or salt solution. Clear? For example, another homogeneous mixture examples you have to remember. I have underlined also. See, air, tap water, sea water, common salt solution, blood, alloys such as brass, bronze, stainless steel, all these are homogeneous mixture. So there may be a question, brass is a days mixture. So you have to remember the examples. Clear? Then we'll discuss about the heterogeneous mixture. What is this? A mixture is said to be heterogeneous if its constituents are not uniformly mixed and doesn't have the same property throughout. For example, a mixture of sand and common salt, it is a heterogeneous mixture because they do not mix uniformly and they do not have the same property throughout. Suppose an example we discussed, the particles of sand and salt can be seen separately. You can mix the sand and salt, but you can identify the salt particles and sand particles. They are not uniformly mixed. If you select a sample of different part of the mixture of this sand and salt, you may find sometimes it is more salty or it may be more sandy. Like this, the taste may be varying. Okay. So this is the definition of homogeneous and heterogeneous mixtures. There are some examples of heterogeneous mixture like iron fillings and sulfur, muddy water which contains clay particles, smoke which is a mixture of carbon particles in the air, kerosene oil and water, petrol and water, dusty air, chalk powder in water. Understood? These are the examples of heterogeneous mixture, not homogeneous, heterogeneous mixture. So there is a difference, it is given in the table 3.1 between the homogeneous mixture and heterogeneous mixture. The question may be asked, differentiate between homogeneous and heterogeneous mixture. Sometimes the question may be there, define homogeneous mixture and give 2-3 examples, or sometimes define heterogeneous mixture, give few examples. Like these questions may be asked. Okay, what is the difference? In homogeneous mixture, the constituents are uniformly mixed, whereas in heterogeneous mixture, it is not uniformly mixed. In homogeneous mixture, it produces or provides same property throughout, whereas in heterogeneous mixture, they do not have same property throughout. In homogeneous mixture, the constituents cannot be easily separated, but in case it can be separated in case of heterogeneous mixture. Okay. Now we'll discuss the mixture, different type of mixtures, varieties of mixtures like solid mixture, solid liquid mixture, liquid mixture. The examples are given. See the table 3.2. Solid mixture is sand and chalk powder, rice and chaff, sand and ammonium chloride. Okay. Solid liquid mixture is salt and water, chalk powder and water, sugar and milk. Like these examples are there. Liquid mixture, it gives oil and water, alcohol and water. Liquid gas mixture, soda, aerated drinks, oxygen in water. Gas mixture, air is the example where different type of gases are mixed. Solid gas mixture, smoke, that is soot particles, that is the carbon particles coming out of the vehicles, plus air, that is called smoke. Okay, so the question may be asked, give 2 examples of solid mixture, solid liquid mixture, or liquid mixture. Like this it may be asked, or in opposite it may be asked, air is a mixture of dash and dash, or dash mixture is air. Clear? Like these questions may be asked. There is a difference between compounds and mixtures. So just now we discussed about the compounds, what are the compounds and what are the mixtures, what are the type of mixtures we discussed. Okay, now there is a difference. What are the difference between compound and mixture? Okay, see, just I am reading, it is there in your book, table 3.3. No, yes, 3.3. In compound, Compound is a pure substance, whereas mixture is impure substance. Compound consists of two or more elements combined chemically. A mixture consists of two or more substances combined, not combined chemically. Okay, so there may be question differentiate compound and mixture. Okay, so you have to remember certain 3-4 points to answer. A compound is always homogeneous, whereas mixture is homogeneous or heterogeneous. Clear? Maybe homogeneous or heterogeneous. Compound, the elements are mixed in a definite composition. A mixture has variable compositions present in any ratio or proportion. Okay, but in case of compound, the fixed ratio is there. Like this, another point is there. Compound, the constituents can only be separated by chemical means, whereas mixtures can be separated by simple physical means. A compound has a fixed melting point and boiling point, whereas mixture doesn't have a fixed melting point and boiling points. Energy, in case of compounds, energy is given out or absorbed in the form of heat and light, whereas mixture doesn't involve any change in energy. Okay, so these are the differences of compound and mixture. So children, this is the first part we discussed. In the next class we will discuss the separation of different type of combinations of the mixtures. Okay, thank you children. Go through your text, underline the points what I have underlined and read thoroughly. Okay, thank you.